So here's today's overarching question. Today's overarching question is, I have data that I've collected from an experiment and survey. Now what? The reason we're asking this question is, if you remember on Friday, we just finished up our experimental/survey unit where we looked at kind of how to collect the data, what's the difference between an experiment and observational study, and like what kind of biases we can get so if we know the data is good or not. But now that we have the data and we know that the data is good, what can we do with it? So there's a couple definitions I want to look at before we kind of go forward. The first thing is what this data is normally called. This data is normally called a random variable, which represents a number value associated with the outcome probability. So like all the data that you collect has a certain percentage of happening, and that's its random variable. Like if I am going to do an experiment where I roll a dice and I see how many times it will take for me to roll a 2. That rolling a 2 has a 1/6 probability of happening, and sometimes that's a little bit harder to figure out based on our experiments, but we can use that to figure out the probability of that happening. The next definitions I want to look at is what kind of random variables you can get. One is called a discrete. That means there's a finite or countable number of possible outcomes. So an example of that is the rolling dice. Like you can only get a 1, a 2, a 3, a 4, a 5, or a 6. Continuous is an uncountable, or there's an unlimited number of possibilities, and normally this is a measured data set. Like if I ask for what's the probability of a certain temperature outside, that is not the possibilities for that isn't discrete, because you could have like 73.24 degrees. Like there's infinitely many choices you could have, so that is not measurable, and it's continuous. For continuous, we're going to find from this range, we'll say from here to here, what percent chance does this have happening? And the discrete, normally you talk about like if you get this one, what's its percent? We'll look at a couple examples and kind of see how that works. So we have two data sets, and we're going to decide if they're discrete or continuous. The first one says, let X represent the number of Fortune 500 companies that have lost money in the previous year. And that is a discrete event. And the reason why that is a discrete event is because there's only a certain number of companies that could lost money. Like that's going to be a countable number, like there might be 10 companies that lost money, or 100, or that is going to be a discrete or countable number. Like you could take all the the companies and count them up on your fingers. And let X represent the volumes of gallons in a 21-gallon tank. Now you would think that this would be discrete, but this would be continuous because I can't count it out. Again, you could get like fractional parts of a gallon. Like I could get like 7.15 gallons of gas that is left in the tank. So it would be really hard to get all the numbers. So this again is kind of this continuous or range. So discrete because I can count this up on my fingers. Continuous because this is going to have decimals, so it could be in a range. Let's try the next example. So after we kind of decide what type of data is, we're going to talk about the guidelines for these probability distributions. So here's the biggest thing behind these probability distributions, and even constructing like a discrete one. Continuous behaves by the same rules. It's just a little bit harder because discrete you tell which outcomes you're going to get, like 1, 2, 3, 4, ... all the way till the last one. Where continuous, you kind of have to be like, the lowest number you can get is here, and the highest number you can get is here, and then you can give some ranges. But the first thing is, when you're doing these things, and the most important part is that any of these distributions, if you add up all their probabilities, they have to be between 0 and 1, and when you add them all up, you get 1, or 100%. If you don't have the probabilities that add up equal 100%, it's not a probability distribution because you're missing some data. Or Yeah, you're missing some data because it has to, like, I can't not get 100%. Everything always has to add up to 100% in stats or probability. Let's look at some examples and see kind of how this works. Okay, so we're going to construct a probability distribution, and it says in Industrial Psychology Administration, a personality inventor test for 150 employees. Each individual was given a score from 1 to 5, which was extremely passive or extremely aggressive. A score of 3 was neutral. The results are shown to the left. Construct a histogram for the probability distribution of X and then graph it. Well, let me get the results real quick. There we go. Okay. So here's the first thing we're going to do. We're going to write this probability distribution. Again, we got the scores, and so now we're going to write the probability distribution has percentages, or the percent chance of something to happen. So we're going to use the skills that we learned in the first chapter to do this very easily. So what is the probability that I get a score of 1, 2, 3, 4, or 5? This, by the way, is a discrete one because you only have 5 options, or it's countable. So we're going to find the probabilities for all these things. So first I'm going to add up the total. Oh, well, they already gave me that total. That was kind of silly. So they're out of the 150 people. Let's figure out what percent got a 1. So 24 divided by 150 is 16%. Let's see what 33 divided by 150 is. It's 22%. Let's see what 42 divided by. So we're just going to keep going through. I'm going to stop writing the percents because that takes a little bit longer. And then the first thing I want to check to make sure I did this right is I should add up all the probabilities and it should equal 100%. And it does. So that's the nice part. We know we did that right. And now if we wanted to make a histogram, that would be easy enough to do. We made that in the second chapter of all the histograms. 3. So this would be like 10%, 20, 30. I guess we don't go past 30. So then 1, 2, 3, 4, 5. And 1 would be up here about halfway in between. 2 would be up here at 22. 3 would be up here at 28, so almost at 30. 4 would be down here at 20. And then 5 would be down here at 15. And there's my rough sketch histogram. That's not very good, but that's okay. But that's basically how you create a probability distribution. Again, we're just using what we learned in the first chapter on how to find a percent, which is the amount that you get over your total. And then we just constructed a histogram, which we learned in the second chapter of how to kind of make those bar graphs. Let's look at the couple last examples. And you won't have to do this today, but it kind of sets up how we're going to do the rest of the problems today. So we have to decide whether these are probability distributions. So the first one we're going to check. And again, the first thing that we should know is, does this add up to 100%? And no, you can't have 117%. So nope. Can't have 107%. This one's an easy no, and the reason why I know it's no is because that is -1. You can't have negative probability. Like, it doesn't make any sense. Like, how do you not get an event 1% of the time? And if you added this up, I don't know if it adds up to 1% or 100%, but again, it doesn't matter because of that negative. So again, if it's a probability distribution, it's got to add up to 100%. If it doesn't, you can't have something happen 100% or 107% of the time. When a coach says give 110%, you're lying. You can't do that. You only can give 100%. Same thing over here, like that -1. you can't have something not happen 1% of a time. So if it has a negative, just rule it out right away. The one last thing I wanted to talk about is this is your assignment today. It shouldn't be too long. Most of it is multiple choice, figuring out whether things are discrete or continuous, just like we did at the beginning. Then talking about like what's the probabilities of different things, like looking at histograms and deciding that. And then deciding what values these should be, which you know that these things should add up to 100%. So I would figure out how much you're off by there, and then deciding whether these things are probability distributions, just like we did at the end. And just some quick summaries of what you've learned and what you're stuck on. As you can see, this one's worth 0 points. It's not going to be graded. So if you're stuck on something, don't worry about like if you put, there's no right answer to that one. So don't overthink it. And on this one, from the quick summary and how it relates, kind of as I talked in the video, you heard some things of where I said, hey, like this is what we did in the past and why we're doing it now. I just want to see if you're picking up on those details. So just please do your best for that one. If you see this one's worth 0 points, but it will be changed later, that's just because for the grade book right now, it's easier for me to not score it, so you can get an accurate score of how you did on the rest of these questions. So if you have any questions, please let me know or send me an email today. Thanks.